Yes, good afternoon. Welcome to Embedded System Laboratory Day 1 class. You no need to think much about this, what kind of the lab session it is, how we are going to handle an online session. Okay, you no need to think about anything. Okay, because already there are few students undergone one value-added course named as Arduino. Am I correct? How many of them attended? Can you raise your hand, please? How many of them attended that value-added course? Bharat, then Bharat raised his hand, then Jayavardhani, Duresh, Jeevita, okay, who are all attended the value-added course conducted during your first semester or second semester holiday, I forgot. Sabri, you didn't attend the course? Many of them have attended, nearly 100 students across EC and EEE have attended. Am I correct? Value-added course conducted by ES Academy. How many of them attended? Let me know a little survey. I think Rohit attended, Siobal attended, Karthikeyan. Okay. So those who are attended, these things may be little boring to you. Okay, you can drop your hand. You can drop your hand. Almost 60% of students, almost more than 40% of students have attended this course. Very much similar, very much similar. Little new things we will learn for sure. Okay, and the platform in which we are going to do means the same platform, Tinkercad. Okay, lateral entry students, don't worry. You will come to know what is that Tinkercad and all with no time. Okay, okay. Let me start my presentation. Okay, let me cover little theory portion without making much delay. Followed by we will have some simulation session as well as some hardware demonstration. Okay, shall I start the class? Anything else you need to discuss from your side? Meantime, everyone find the chat box. Click the link available for the particular class. Don't mix and join. A class is a separate link. For B class, it is a separate link. Okay. Click the link. Join as a student. Okay. Give the nickname as your permanent role number. Okay. Yes. Let me start present my screen first of all. Okay, wait a minute. Anything else you need to ask? Sir, my humble request is try to arrange a laptop at any cost. Without laptop, it is little difficult to handle this particular software. Already many of them know about the particular cloud software. Doing in a mobile phone is very tedious process. Okay. First of all, I welcome you all to the Embedded System Laboratory. Here we have some set of experiments. Okay, we will see one by one. Let me take a maximum of 10 to 15 minutes for the introduction. Then immediately we will get into the first exercise. Okay, yes. What we are going to do in the embedded system? What is our schedule? How we are going to plan the experiments? So these are all some list of experiments we are going to cover during the session. In that you may study. Can anyone read behalf of me? What is the name of the first experiment? Can anyone read it loudly? What is the name of the first experiment? What is the name of the first experiment, please? Anyone? Is it screen is visible? Hello?
Yes, sir.
Hello?
Blinking
Yes,
of
can you
LED
read? Using?
blinking of LED using LPC 2148.
Which one is new to you? That last word only. Am I correct? That LPC 2148. Am I correct? Am I correct? Hello?
Yes,
Okay,
sir.
read the name. Only the variant LPC 2148 is a new to you. Any guess what it may be? LPC 2148, what it may be? Any guess? கொஞ்சம் குயிக்காக இன்ட்ராக்ட் பண்ணணும். ஸோ I see, okay, I agree. Compare with your theory portion and tell what it is. In theory, we are studying something. Controller, okay, I am happy. Specific, more specific I want. We are going to study one important controller in our theory portion. You are aware of that term? ARM, am I correct? Advanced Risk Mission, ARM. So this for few experiments, the animation may be little up, okay. Actually, first 4 experiments you are going to do with the LPC 2148, that is your ARM, okay. Remaining experiments and all, we are going to deal with the Arduino, okay. The last 2 experiment number 11 and 12, combinedly either ARM or Arduino we will do, okay. So the experiments are very simple. Interfacing of LED, switch, LCD, 4x4 matrix, keypad, then some timer operation. These are all related with the ARM. Then in Arduino, we are going to deal with the LED, LCD, relay, buzzer, temperature sensor, switches, joystick, light sensor, IR sensor, and 2 protocols, okay. Don't worry about this. It is very much similar to your microcontroller lab, okay. Only the controller and the way in which we are going to write the code is differs, okay. If anyone want, you can take a screenshot, or these things are already available in your syllabus. You can get it from there, okay. Yes, then lab evaluation process is very important. As usual, your lab preparation and lab performance is going to carry 60 marks. Then your record submission going to carry 40 marks. Put together, you are going to get 100 marks. So you know very well how we are handling this observation portion in the online platform. Usually, we will circulate a Google form to you. There you need to answer few questions, followed by you need to attach your work, okay, the simulation work. So if you did that, immediately you will get a 60 mark, okay, with no time. Then record submission alone, you need to write and submit the content, okay. So that carries 40 marks. So it's very simple. We don't need to spend much time over there. What is the overview of the embedded lab? It's very simple. Only 3 blocks. Can you read what are the 3 blocks? And if possible, can you elaborate it, please? Purushothaman 504. Purushothaman. Can you make an attempt, please, Purushothaman? Enna blocks irukku Purushothaman in front of you? You are having some blocks. Am I correct?
Yes.
Hello.
Yes, sir.
Enna blocks irukku Purushothaman? First enna irukku? Very first block. Make attempt, no issue. Purushothaman. Okay, Arun 108. Arun. Who I can call? Okay, Aravind. Last overall, Akshay Prasad, are you there? Akshay Prasad. Hello. Yes, Akshay Prasad. Can you read the block names listed in front of you? Nee ready irukka, communication ready alla. Okay, last call. Abhinaya, konjam nee unmute panni sollu paakalam. Enna block irukku?
Sir, input
louder, yes.
processing unit,
Okay.
output, sir.
Output, that's all. Okay. Abhinaya, input and output நம்ம எங்க இருந்து எடுப்போம்? அதாவது லேப்ல நம்ம எப்படி யூஸ் பண்ணோம்? மைக்ரோ ப்ராசஸர்ல மைக்ரோ கண்ட்ரோலர் இன்புட் அவுட்புட் எப்படி யூஸ் பண்ணோம்? எனி ஐடியா? Any idea? Okay, are you aware of this board, Abhinaya? Are you aware of this board? Are you aware of this board? Yes? Yes? Hello? Abhinaya, ஒரு green colorல ஒரு board தெரியல, அந்த board பார்த்திருக்கோமா? You can see the same board in front of the camera also. Can you see this board? Can you see? Are you aware of this board? Hello? Can I the board எங்கேயா பார்த்திருக்கோமா? Is it everyone can see the camera view also in front of your screen?
Yes, sir.
What is this? What is this? 8 yellow color rounds. கொஞ்சம் குயிக்கா சொல்லுங்க.
சார் தெரியல சார்.
கேமரா வியூ. கேமரானா நீ ஸ்லைட்லயே பாருங்க. ஸ்லைட்லயே தெரியுமே மொபைல் போன்ல தெரியலையா?
சார் எல்இடி சார்.
Is it visible or not?
Visible
Yes, sir, visible.
Visible, sir.
Visible. 8 LEDs. Okay. What about this fellow? Oh, wait a minute. What about this one? This one. This is also LED. Am I correct? Am I correct?
Yes, sir.
But it is a tricolor LED. Okay. What about this? What about this?
LCD display.
LCD. Okay. What about this? What about this? What about this?
Relay.
Relay. Very good. What about this? Ange elidi irukku.
Buzzer.
Buzzer. Okay. What about this? What about this?
Switch.
Switch. That's all. Very good. So this is your input output board. Am I correct? Input output board. So using this board, we can give input and output signal to our processing unit. Okay. In your microprocessor and microcontroller, you used different controllers, okay, and processors. Here we are going to deal with only two. One is your ARM development board. The same board you can see in the camera view also. Okay. Let me show it in the camera view. Can you see the ARM development board? Can you see the ARM development board in the camera?
Yes, sir.
Yes. So it's also looks like your controller board. It is called as a development board. We'll see what is development board in later. Okay. Here you have some port pins. Here you have some port pins. Using the port pins, we can interface any external devices. Here the heart of this is your ARM controller. Can you see this square box, the chip, the square chip? Can you see in the camera?
Yes, sir.
This is your what? LPC2148 ARM controller. Okay. Nearby you have a crystal and some other components. You don't need to bother about it. You need to aware of only this variant LPC2148 and this chip. Okay. Then the second one is well known to you people. This is your what? What we are showing in front of the camera? Arduino. Am I correct? So Arduino, we will discuss in detail. I am showing two different packages. What is difference in these two board? Can anyone tell me? What is the difference in these two board?
Size.
Size of what? Size of what? Size of what?
Chip.
So here it is SMD package. Am I correct? This is an SMD quad package. 4 sides you have a pin. This is DIP package. Is it clear, sir? Is it clear? So here, what you have to note down is that controller name what you are using. Please note down. It uses Atmega 328 8-bit controller. Here we are going to use ARM LPC2148 32-bit controller or processor. Okay. Okay. What is the size of this? What is the size of this? 32-bit. What is the size of this? What is the size of this? Please reply. Tungirada, please reply. Okay, detail வரும்போது கூட note பண்ணிக்கோ. First we will get into the Arduino. Okay, so what is Arduino? It is an open source hardware. I hope you people are aware of the symbol, the setting, that gear symbol with some opening. This is called a open source hardware. You people are aware of open source software also. Can you name few open source softwares, please? ஏதாவது ஒன்று ரெண்டு ஓப்பன் சோர்ஸ் சாஃப்ட்வேர் சொல்லலாமா? உனக்கு தெரிஞ்ச சாஃப்ட்வேர் கொஞ்சம் குயிக்கா. ஈவன் யூ கேன் டைப் இட் இன் த சேட் பாக்ஸ். ஓப்பன் சோர்ஸ் சாஃப்ட்வேர், ஓப்பன் சோர்ஸ் சாஃப்ட்வேர் உனக்கு தெரிஞ்சது. வித் நோ டைம் சபரி டைப் டிங்கர்கேட். ஓகே, எனி அதர் சாஃப்ட்வேர் யூ நோ? VLab, LabVIEW. Hey, who told LabVIEW is an open source software? Sabari, NA giving, you have to get license for that. Okay. A student's version may be free one. Any other, see, you people know many operating systems also as an open source. Can you tell me few operating? Firefox, okay, then some operating system I am asking. You are typing some browsers. Linux, hi, Rohite, Windows வந்து ஃப்ரீயா கொடுக்குறாங்களா? தூக்கி உள்ள வச்சிருவாங்க. சரியா? Windows is not a free one. It's a licensed OS. Okay, Linux, very good. Linux, Red Hat. Plenty of things are available as a open source. Okay, why this particular Arduino hardware is hacked Microsoft? Okay. See, let me come to the point here. What is this Arduino? So Arduino is an open source hardware. What it means, by getting the schematic diagram of this Arduino development board, anyone can develop their own development tools. So that is open source hardware open source, and the software what you are going to use for this is Arduino IDE. Again, that software is also a open source. Okay, so what is the key point in the open source means? What is the key point in the open source? Whenever you are spelling about the open source, you will find many forum support. Open source நிறைய பேர் work பண்ணுவாங்க. Together you can work and build many things. Okay, yes. Now we will come to that controller. Atmega 328 is the variant what we are using in the Arduino board. It is an 8-bit microcontroller. It has onboard power supply. What it means? If you people want to correlate these points straight away in the hardware, let me make this image nearby to you, and I can explain what is that onboard power supply. Very simple. Here I am having the USB port, and here we have one power jack. Then we have V-in and ground. Okay, these are all three options to power the board. So very simple. I can connect it to a simple USB cable or the power jack, or I can simply connect it in V-in and ground. I hope this V-in and ground is visible to you. Am I correct? V-in and ground. So in the three options, you can use any one option at a time to power the board. Here in USB port, we will straight away give you 5 volt. Okay, no issue. But here, using this jack, we can give wider range of voltage, that is from 7 to 20 volt. But my controller operates with the voltage of plus 5 volt. Then how to regulate my input voltage? Can you see the small tiny regulator in front of nearby the power jack? Camera இங்க ஒரு regulator பார்க்க முடியுதா? ஒரு 3 pin ஓட. Can you see this regulator in your camera, please? Can you see? இங்க ஒரு சின்ன regulator தெரியுதா சார்? Hello?
Sir.
What is the purpose of the regulator? To regulate your DC input voltage into a record level. So regulator will regulates and give exactly 5 volt to the controller. Okay. What else they have given? USB port, you know. It easily communicates with PC. How I can communicate? If I connect the USB cable, we can communicate with with the personal computer or your laptop. It uses Atmel microcontroller chip. That's all. Okay, it is an open source hardware. We have discussed what is open source hardware. Here the takeaway point is it's an 8-bit controller. Then your Arduino have various type of boards. Arduino supplies various type. Here we shown only limited versions. Beyond this, you have plenty of versions available. Okay, I don't need to worry about that. I will point to little key points in this variant. Okay, this lily pad, this Arduino Mini, Arduino Nano, Arduino BT. These are all some special development boards used for some specific task. Okay, can anyone tell me what is this BT? What is this BT? Arduino BT. BT, any guess? BT. Related to wireless communication. Can anyone unmute and tell you what is BT?
Bluetooth.
Very good. So this development board inbuilt with the Bluetooth. Can you see the Bluetooth arrangement over there? What is the beauty of Arduino Nano and Mini? From the name itself, it implies that it is a tiny in size. So whenever you are doing some IoT product or some low peripheral projects, you don't need to go with the Arduino Uno. You can go with the Nano or Mini. Okay. Then Mega from the name itself, it's a big in size. What it means? It has more peripherals to interface. It's a very wonderful gift in the Arduino. Even in 2015, your seniors did one project at the time. They found their Arduino Uno is not sufficient to connect their hardware peripherals. At the time, they bought this and they did a nice project. Okay, the lily pad, it is like a wearable one, circular. You can stitch it in your clothes. Cloth stitch panni. Defense personnel, cloth they have some sensors and control units. So wearable sensors and wearable controls also available in the market. Under the Arduino, the lily pad is the one you can stitch it in your cloth, and you can connect some solar panels to power this controller. Thereby, you can enjoy some applications. So the one question and one solution in the slide is we have plenty of questions, but in that time you will find difficulty how to learn all the individual controller and write the code. Don't worry, our Arduino IDE will support all the different variants, and the coding part is very similar in all the variant. Only the pin number you need to collect from the hardware, then you need to use it. Okay, if you know more than enough to work with all other variants. Okay, yes. Then what are the things we are going to do? See, plenty of things are available. These are all straight away you can say Arduino compatibility sensor. What it means? See, our ARM, the ARM controller deals with 3.3 volt. 3.3 volt. My Arduino deals with 5 volt. 5 volt. You people know well, whenever you do project, you want buy from the market, most of the time, our sensors operating voltage falls with 5 volt. Am I correct, sir? Am I correct? So whatever the sensors readily available in the market, directly, immediately sit and fit with your Arduino. This is one powerful thing. Because in olden days and all, whenever we do project, any sensor, okay, any signal conditioning things we need to do means everything we need to start from the scratch. Okay, so we need to buy a sensor, then we need to create some signal conditioning circuit, then only the output can be interfaced with your control. But nowadays, this part is eliminated. Most of the time, you are getting the sensor in the modular type. Modular type means give VCC and ground and take signal, connect to your controller. Only 3-step process. Only 3-step process. Connect plus, connect minus, take signal output. This output may be 0 or 1 or some range of output 0 to 1. What it means? What is the difference between 0 or 1 or 0 to 1? Any idea? Any idea what it is? 0 to 1, logic 0 to logic high. In between you can sense many ranges. What it means? What is the difference between 0 and 1 or 0 to 1? Anyone can answer. Hello, sir? What it means? 0 or 1 or 0 to 1? What is the meaning? Any idea? Hello? Hello? Sir, நான் இருக்கேனா சார்? யாராவது கொஞ்சம் ரிப்ளை பண்ணுங்க பார்க்கலாம்.
Yes, sir. Yes, sir.
சார் உங்களை சொல்ல சார் பையங்கள. ஹலோ சார், தூங்கிட்டோமா எல்லாரும்? தியரி போர்னா சொல்லி இமீடியட்டா நம்ம லேப் ஒர்க் அவுட் பண்ண ஓடிடலாம். கொஞ்சம் குயிக் இதை மட்டும் சொல்லு. 0,1, 0 to 1. What is the difference between these two? டேய், செகண்ட் இயர் பையனுக்கு இப்போ எடுத்துட்டு இருக்கோம். அவங்க கேட்டா டக்கு இல்லைன்னு சொல்லியிருப்பான். யாருமே இல்லையா?
Sir, 0, 1 ரெண்டே ஆபரேஷன்ஸ் அந்த மாதிரி.
அதுக்கு என்ன சிஸ்டம்? அந்த சிஸ்டம்க்கு என்ன பேரு?
Digital.
நாளைக்கு வந்து
Sir, binary system, sir.
ப்ளீஸ் பைனரி ஆர் டிஜிட்டல். தென் இது என்ன சார்? 0 to 1 0 to 1. அந்த சாமிகளா? analog. In our universe, if you design any system, 90% it will fall only in these two categories, analog and digital. What about the 10%? Remaining 10% at present using some protocols. It won't give straight away the values. You need to decode and get the value. That and all we will see later. Okay, wow. So microcontroller readily available, so you can enjoy a lot using these components. Then few more. So here this slide, except keypad all are except keypad all are
Digital.
no. All are display units. Or else it is an output devices. Okay. Yes. Then we'll get into Arduino Uno in a very short note. We will finish. Okay. Introduction. Arduino Uno. You know the board. I have shown the board in front of you. The operating voltage is 5 volt. First step, you can power using the USB cable. Okay, wow. Can you see the camera view, please? I'm sure. Okay, camera view. Maybe okay, last so in the USB port use panni inga power pannalam, or using the power jack, or Vin and ground. 3 ways are available to power your Arduino board, but at a time you can use any one to power. That is a very first one. Then power pins. So Arduino power pins I can compare immediately with the hardware because we don't find time to do everything individually. So we will do parallel processing. Can you see the Arduino board in front of you? Here, left hand side and right hand side, you have a set of pins. Whatever you are seeing in the slide is this portion. Can anyone read what is present in front of you? Can you read? What is the first one? IO. Can anyone read it, please? IO. Is it visible? Hello? Is it visible?
Yes, sir.
Anyone please read it. What is the first one? IO
REF.
IO reference. Next one?
Preset.
Okay. Next one?
3.3 volt.
Next one?
5 volt.
Then?
Ground.
Then?
Vin.
That's all. The gang of these pins are said to be power pins. Okay. Come to here. Can you read it? Can you read it now? Can you read it, these numbers, please? What are all these numbers? Start from down to up. Start from down to up. Please read it. Please read it. 0, quick, 0,
0, 1, 2, 3, 4,
4,
5,
5, 6, 7, up to
13.
13. Above 13, what you have? Above 13, what you have?
Ground and reference.
Ground and A reference. Analog reference. Please note down. This analog reference pin. Below that, you have a ground pin. These pins are called digital input and output pins. What it means? Input and output na enna meaning? These pins have two functions. You can use it as either input or output. Okay. And also, you can observe one thing. Can you find one tilde symbol in few pin numbers? Tilde symbol. Tilde symbol. What are all the pin numbers having tilde symbol? Tilde symbol. And then the pin tilde symbol.
3, 5, 6, 10, 11.
3, 5.
6, 10, 11.
3, 5, then 3, 5, then
6,
3, 5, okay, 6, then
9, 10, 11.
9, 10, 11, 9, 10, 11. So those pins are called what? Here, board itself it is written. Please read it. What is the tilde means? What is the tilde symbol means? Digital PWM pins. Digital PWM pins. Okay. What about this 0 and 1? Nearby 0 and 1 we have TX and RX. Can you see what is the TX and RX? TX and RX. 3 the sir. What is the TX and RX? Any idea? TX and RX. Any idea? Konja quick sir. TX and RX. TX and RX. Any idea?
0 and 1.
No. TX and RX na enna meaning? Serial communication, transmit and receive. Likewise, these digital input output pins have some multi-functions that we will see later. Now you come to here, this portion. Can you read it? Can you read it what it is?
A0, A1, A2, A3, A4, A5.
A0, A1, A2, A3, A4, A5. What it is?
Analog pins.
Nearby analog
Unlock pins, sir.
input pins. Analog input pins. Please note down. Analog input pins. That's all. That's all in this hardware portion. See here. This is power pin. First one is reset. Then 3.3 volt, 5 volt, ground. Then VIN. Except these two pins, remaining all pins are, the reset, VIN, ground. These three pins are input pins. The 3.3 and 5 volt is the output pin. That means from the board, we can take 3.3 volt with respect to ground or 5 volt with respect to ground. What is the need of that? Whenever you need to power any external sensors, you no need to design any power circuit board. Okay, you can take it straight away from this development board. Okay, so that's all regarding power pin. Beyond that, you have a hardware reset button. Then you have USB to serial IC. What is the purpose of this? We will study in theory portion. Don't worry. Then you have 60 megahertz crystal oscillator. Note panni vechiko. 16 megahertz. This crystal is used for USB to serial communication, not for this controller. This controller have one more. This is my Atmega 328 controller. This controller has again 60 megahertz ceramic resonator. This is also one type of oscillator. Please make a note of this term, resonator, ceramic resonator. Browse next class. Okay, so you have two crystal, two or in 16 megahertz frequency. One is used for communication, another one is used for the controller operation. So this is an external input to your controller. Okay. So what else? What else? This is our digital input output pin. You people can take a screenshot of this one. This tabular column gives some inputs regarding your board. First one is the controller brand name, then operating voltage. The input voltage 7 to 12 means, that means the power jack, this power, black color power jack. I have shown the black color power jack now. If you watch your camera also, you can check, cross check. This power jack, using this power jack, here you can apply 7 to 12 volt as an input. That will be regulated and fed it back to your controller with the operating voltage of 5 volt. Okay. Then digital input output pins labeled from 0 to 13, therefore 14 pins are available. Similarly, analog pins are labeled as A0 to A5, therefore you have a 6 pins. And then in the digital input output pins, there are 6 pins used for some dedicated application called PWM function, pulse width modulation, that we will discuss detailing later. Okay. Then what is the current capability of your port pins? Current capability is, please note down, it is only 20 milliampere. This current rating will vary with the controller to controller. In Arduino Uno, we use this Atmel Atmega 328. That controller supports up to 20 milliampere. Then flash memory, 32 kilobyte. Okay. Out of the 32 kilobyte, 0.5 kilobyte is used for boot loading purpose. Then SRAM 2 kilobyte, clock speed 16 megahertz. The data, this is the some clips in your board. Okay. Then you know well. Can anyone tell me what is the thing I am highlighting at present? What is the thing I am highlighting at present? Please tell it. What I am highlighting now?
Analog inputs.
Analog input. Very good. Okay. Next. What is this? These pins. These pins are called as power pins. Power pins. Thank you. So take a screenshot. No need to buy that. Okay. If you buy a board itself, you have a legends. Okay. It's printed. So you can read the labels easily and you can access it. This is an overview what we have discussed. Okay. Let me skip these 2 slides. Okay. Then digital input output pins, elaborately we have discussed. Here the only one thing you need to remember is the pin number 0 and 1 is used for serial communication. And one more thing, one more interesting thing, whenever you buy development boards, the particular developer will give some testing purpose. They will give some LED. Can you see that ARM development mode in your camera? ARM development mode. Here you have one LED. Can you see this LED? Can you see this LED? Nearby they have written something, PWR. What it is? What it may be? PWR LED. Some abbreviation. Any guess? Konja quick kanna? PWR. PWR.
The pulse with radiation.
No. Avlo depth ala pogada. இப்போ ஒரு எலக்ட்ரிக்கல் சிஸ்டம் நம்ம பவர் ஆன் பண்ணா நமக்கு ஒரு இண்டிகேஷன் கொடுக்கணும், கரெக்டா? So this is the power on LED. Then you have one more LED here. Can you see one more LED here? UL அப்படின ஒரு LED இருக்கா? This LED is connected to one port pin. What is the port pin number? We will discuss later. But what is the idea behind this kind of LEDs? It's very important. See here. Again, in this board, how many LEDs are there? I think one LED is missing in this board. Let me show this board. Yes. Can you see how many LEDs are there? First on, then RX, TX, and L. Can you see 4 LEDs? Can you see 4 LEDs?
Yes, sir.
Any idea? What is that on LED? On LED purpose என்னவா இருக்கு?
Board on
It is the
indicate.
power on LED, that's all. RX receive signal. TX transmit signal. What about this L? What about this L? This
Load.
LED is one of the, you can take it for testing purpose. Whenever you want to test the board is working or not, as given in the slide, the onboard LED is connected to pin number 13. Pin number 13. Where the pin number 13 is present? Here. Here we have a pin number 13. In this 13th pin, the LED is already permanently connected in the development port. What is the purpose of that? What is the purpose of that? Whenever you are writing some new coding, if you want to check whether your controller is working perfectly, you can write the code to this LED and you can check it. That's all. Okay? Yes. Then these pins can be configured as either input or output. Then what else? PW pins. Okay, they're using this tilde symbol you can find. Then these are all analog input pins. Analog input pins. Then this is the entire discussion what we have discussed so far. Okay, multiple times you are seeing the same diagram. Why means want to get those content in your mind. Therefore, only we put it in multiple times. Okay. Yes. Now we will come to the Arduino coding part. Coding part is very simple. It is not like your 8085 or 8051 or 8255, 8952. Not much complexity. Here we are using one coding technique called embedded C. What is the name of the coding? Embedded C. You know these many languages. Am I correct, sir? C, C++, Java, Python, PHP script. Many languages. Correct, sir? You know, nowadays the languages are getting introduced every day. They are introducing some languages. What is the beauty of our ID means, our Arduino ID means, in our Arduino ID, you can type C++, you can type Java, you can type PHP code, you can type HTML coding also. Your JSON command also you can type it in this Arduino ID. Okay, but in a simple sense and send operation or some other simple applications, we will stick with only embedded C. Embedded C. Okay. So embedded C we use whenever we start using at the time we will come to know. Okay. Simple comparison between C and embedded C is C is general one. Embedded C is hardware specific. Nam over hardware embedded C oda syntax maru. Okay, it is a subset of conventional C program. This is hardware independent, but it is hardware dependent. Okay, Arduino you are going to use some set of C code. For ARM, you are going to use some set of C code. Okay, so standard compiler is required. Here you have a cross compiler. What it means, cross compiler? I can write the code in one system, and I can take the code and work in some other system. Cross compiler. Okay, one OS la nama hex file create panni இன்னொரு hardware la kondu poi run பண்ண வைக்க முடியும். That is the platform independent and dependent. Very good. That's meaning. Okay, cross compiler and standard compilers. Then this is OS dependent. This is hardware dependent. Okay, sir. This is the difference in between your normal C and embedded C. Arduino you have IDE. I can show the demo. Theory most of the time. This is your Arduino IDE. If you simply open your IDE by double click over there, how to install the software and all, It's very simple. Exe file is available. Simply go to Google. Simply go to Google and type Arduino software. It will take you to Arduino website. In the Arduino website, if you click and browse the Arduino website, see the beauty of the software. It can use it in Windows, Linux, and Mac. Okay, different OS you can operate this. Okay, so here you can click Windows 7 and the newer or the zip file. That is up to you. Simply click. It will ask one thing, even though it is an open source software. They will ask you to donate something. If you wish to donate, you can wish, or else simply click just download. Thereby, can you see the bottom window? It is getting downloading. Can you see? Can you observe this? I am
Yes, sir.
downloading this software with no time. Okay. So then download. Then it is a exe file. Double click. Click. Next, and finish. Okay. If you do that, you will get this ID in your system. Here, by default, they have written something. What they have written? They have written two functions: void setup and void loop. So what we are going to do and what we need to do, they have given the hint. Please read it. Put your setup code here to run once. What it means? In the void setup, whatever thing you are writing in this two braces inside, this code will run only one time. Then in void loop, put your main code here to run repeatedly n number of times. Unless otherwise you turn off the power, it will be in this loop only. Okay, then you may ask when this setup code will run. The setup code will run in different scenarios. The first one, whenever you turn on your hardware, very first time, it will start run from void setup. Then it will get into void loop, and it will keep on loop in the void. That means during start it will run. Then it will jump to void loop and it will keep on running. Then if you want to force your system to go back, what we can do? No need to power off. You have one more option in your hardware as well as in your software setup is called, can you guess what it is? I want to make the system to go up. Enna pannalam hardware. You have one option called reset. Have you seen the reset button in your hardware? This button, the tiny push button nearby the USB port. If you press once, whatever the code you have written here, it will get bypassed. It will jump back to the void setup. It will again executes one, then it will come. All the time. The condition is this particular loop execute only once. The iteration is single iteration. இதுவரைக்கும் யாருக்கா டவுட் இருக்கா? இதுவரைக்கும் யாருக்கா டவுட் இருக்கா? நான் நிறைய பேசிட்டே போயிட்டு இருக்கேன். யாருக்கா டவுட் இருக்கா சார்? ஹலோ சார், யாருக்கா டவுட் இருக்கா? Any doubt from your side?
No, sir.
No. Shall I proceed in this phase? Okay. The Arduino IDE இருக்க menus எல்லாம் நான் இப்போ explain பண்ணல. ஓகேவா? It is like our MS Office only. Whenever we do some hardware demonstration, at the time we will explain this menu. Okay. The setup and loop I have explained with the help of your IDE itself. Here one new thing to you people is sketch. The structure of the program, what you are writing in the Arduino IDE is said to be Arduino sketch. Arduino sketch. You can observe the same thing in the file name also. Can anyone? Okay, let me save the file. Simply give Ctrl S. Can you see what is the default name of your file? It may not be visible to you people much clarity way. Let me type it in the chat box. Please read it. What is the name of the file? By default, the software is assigned. Please read it. Please read it. What it is? What is the default name of your coding? Sketch underscore today's date. Am I correct, sir? Am I correct, sir? August 24. So the IDE will create the name by default sketch underscore that particular date. Okay, wow. So in the structure pair is sketching pair. Okay, wow. Yes. Fairness, sir. Now we will go to coding part. Everyone are requested to take any one observation note and note down this syntax. It's very, very easy and important. Okay, we told that these digital input output pins, these pins have multiple functionality. Am I correct, sir? In the pins two purpose. Villain hero. நம்ம படத்துல ரெண்டு ரோல் நடிப்பார் அதே மாதிரி here this hardware pins port pins going to serve two function input or output. What it means input or output. Anyone can clarify what is or, why it is or? Hello sir. Or can mean input or output any meaning. Hello? Why
Sir, we can configure our wish, sir. If input means we can configure as input,
okay.
Otherwise output.
Okay, or what it means? Input or output. Here they didn't tell input and output. What it means?
Any one at a time.
Who told the answer? Who told the answer? Who told the answer? Jagadish have typed. Who unmuted and told that? At a time, you can configure it as either input or output. In olden days, when you were microprocessor, microcontroller and all, what you people will do? You have some set of registers. Am I correct? You have some set of registers. In that register, you will pass either 0 or 1. Am I correct? Am I correct? If you pass 0, it will serve one function. You pass 1, it will serve another function. Am I correct? Am I correct, sir? 0 input or output. 1 input or output. Am I correct? But here what we are going to do with this IDE. Again, obviously, here you have some registers. You need to configure the registers. But the thing is that we are not going to touch the registers straight away. We are going to write only the embedded C coding. Okay, the coding is a syntax. Note paniklama. Very first syntax. Pin mode, pin number, comma, mode. It is the very first syntax. Note paniklama, sir. Pin mode. The argument enna pass pannu, pin number, comma, mode. Pin number for example sir 13. Mode, two types of mode you can configure, either input or output. Input na capital input type output na capital output type that's all. Then pin mode the M capital letter. Can you observe that very clearly? M is cap. Why it is caps? Why it is caps? So this is the syntax designed by the IDE person. So no meaning at all, because here you can't create any space in between. So there are some codings, it won't allow you any special character and it won't give some spaces in between. So if you read easier, they will change the case. Okay, lower case to upper case, it is easy to read. Okay, that's all. So I hope everyone note down this. Yes? Okay. The very first and foremost thing, we need to configure the pin number. Okay, where we will use this coding. Soon we are going to see where we are going to use this. Okay, this uppercase letter, case sensitive, please note down. Then come to the digital function. So first and foremost thing, we decided we are going to use the pin as a input or output. First task நம்ம என்ன பண்ணிட்டோம், input output and decide பண்ணிட்டோம். Please, you people can give me, let me draw two cases. You tell me in which case you will consider as the input, in which case you will consider as the output. I am giving two different cases to you. Tell me, what are the case 1 and case 2? Consider in both the cases we are using pin number 13. Please tell me appropriate pin mode to select to make operation with these two exercises. In 13 we will configure what kind of device it is, input or output device. Input or output device. Any idea? Any idea? Obviously, it is output device. Output device. Then what syntax we need to write? What syntax we need to write? What syntax we need to write? Pin, caps lock pin, caps lock pin, pin, capital MOD, pin mode, open bracket, pin number 13, comma. Is it clear, dear students? Is it clear, dear students? Is it clear? Is it clear? Any doubt in this? Any doubt in this? Arka doubt ruka? Arka doubt
No,
ruka
sir.
the syntax la? Syntax arka doubt ruka? Pin mode capital M output. Okay. What about this one? What about this one? What about this one? What you will do here? இதுக்கு என்ன பண்ணணும்? Any idea? Any idea? Second case la enna connect பண்ணிருக்கோம் கொஞ்சம் குயிக்கா. Second case la enna connect பண்ணிருக்கோம்? We have connected a switch. Whether the switch is the input device or output device. It is an input device, obviously. What syntax I need to type? Pin mode 13 comma input. That's all. That's all. In this way, we are going to use the pin mode configuration. Okay, well, yes. Now I want to make this LED to turn on. By reading the circuit configuration, can anyone tell me what logic we need to send it from the pin number 13? Or the voltage level? Voltage level na plus 5 volt, 0 volt. Logic level abdina 1, 0. You can tell me yes. Srigiri gave the answer as logic 1, that is plus 5 volt. That means we need to deliver plus 5 volt from this pin to make this LED to on. Similarly, if I want to make this LED to off, what we need to do? What we need to do? Any idea? What we need to do? What we need to do? கொஞ்சம் அன்மியூட் பண்ணி பேசலாம். ஸ்ரீகிரி ஒருத்தவங்க தான் டைப் பண்றான், மற்றவங்க எல்லாம் தூங்குறாங்க. Praveen, very good Praveen. You need to pass 0 volt or logic 0. How to do that? How to do that? How to do that? Whatever we are doing is a output action. So output as per this ID is concerned, it is going to consider as a write. Slide la paakalama. Write. That is named as digital write. Okay, digital write. When the argument kulla nama appo enna pass pananum? We need to specify two things. One is the pin number. The second one is the value what we need to pass. What is the pin number we have used? We have used pin number 13 in our case. Am I correct, sir? Appa enna pannom? What we need to do? Digital write off pin number 13 comma high LED on ayirum. Pin number 13 comma low LED off ayirum. Very simple exercise. Okay, please note down the second syntax: digital write pin number comma logic value. Here I can interrupt and tell you one thing to you people. You have two options. here. The first one, As we discussed in the slide, digital, stay sensitive, digital, W-R-I-T, digital write-off, pin number 13, comma, you can type high, capital H-I-G-H in type பண்ணலாம். Okay, sir? You can type H-I-G-H in type பண்ணலாம். Or else you have one more option. Instead of high, instead of typing high, you can simply type logic 1. There are two ways to write this action. And you tell me, if I want to make the same pin to logic low, what may be the another option? What may be the another option? Simply I can pass 0. Simply I can pass 0. Okay? Yes, that's all. That's all. That's all the thing related to the digital write function. Okay, wow. Yes. Now, no time. We will come here. We will come here. Please observe the animation. Please observe the animation. What it is. What it is. What it is. In a
Light on.
animation. Light blinking. Blinking. Can anyone elaborate the blinking action?
They're on and off continuously looping.
On and off continuously in the loop is very good. Okay, on and off. Srihari gave one more thing. On, delay, off. Is it on, delay, off is sufficient, Srihari? On, delay, off is sufficient? Okay, it's in the loop. Okay, can anyone find what is the mistake in the Srihari statement? Okay, we will hold for some time. How to create the delay? How we create a delay in our controller or microprocessor means we will put some dummy for loop. Am I correct? You will take some register. You take some register. You will pass some value. Then you will decrement. Then you will check for carry. Sorry, the decrement panita the condition check pannuva. If not, you will go back. Like this, you will do number of iterations. But here, the Arduino IDE, they give one more function called delay. Please note down the third syntax what we are learning today. Delay, within the bracket, whatever the value you type, it is considered as a milliseconds. That means 1000 milliseconds is equal to 1 second. And also, we have one more syntax that is called delay microseconds. So whenever you want to do some time specific applications, that time you need to operate in a micro level, you can use this syntax. Again, read it. Delay microseconds. The syntax and all very much similar to our English language. So now the first task, people are going to implement this exercise. This is our first experiment, but as per the number, it is experiment number 5A. Interfacing of LED with Arduino. Okay, port pin number, it is a fill in the blanks. Here you need to write 13. Enna pin number ni eludano? Pin number 13. Please write it. So whenever you are writing the record, at that time you need to fill in the blanks. Fill in the blanks. Pin number 13 we are going to try. Okay. What is the flow chart given? The interfacing diagram we will come to later. What is the flow chart? Very simple. Start, configure the pin as the output, create a loop, make the pin to logic high, then give delay, then give low, then give delay. I am not going to show the coding to you people because you people know well how to write, where to write. My humble request, everyone want to do the exercise parallelly. Okay, I am sharing once again your Tinkercad class credentials. A class students, please click A class link and do join. Your nickname is your permanent roll number. Okay, for few students may not know what is the Tinkercad. For those people, let me give introduction how to do this. Okay, let me give one. Many of them has joined already. How many of them joined? Vasant kuda join பண்ணிட்டாரு நம்ம மத்த ஆளுகளும் join பண்ணாம இருக்கா. Is it anyone knows how to join this? Else shall I continue the exercise? Selvaraj 116 Jayavardhani நீங்க எல்லாம் என்ன பண்ணிருக்கீங்கன்னா உங்க அக்கவுண்ட் யூஸ் பண்ணி ஜாயின் பண்ணிருக்கீங்க. Let me show to teach the procedure once. Go to Tinkercad, click join now, then click students join a class. Idu click pananum. Students join a class, followed by it will ask the class code. Where you will find the class code? Here you have the class code. So in the extension la pathina ungalku oru class code irukku. நீ ஸ்ட்ரெயிட்டா அந்த லிங்கை கிளிக் பண்ணேன்னு வச்சுக்கோங்க. ஃபார் எக்ஸாம்பிள் ஐ எம் கிளிக்கிங் EEE கிளாஸ் கிளிக் பண்ணனா பாரு டைரக்டா அந்த கிளாஸ்க்குள்ள வந்துருச்சு. இஸ் இட் ஓகே? இது ரொம்ப சிம்பிளான டாஸ்க். நீ இந்த சாட் பாக்ஸ் இருக்க லிங்கை கிளிக் பண்ண அப்படின்னா டைரக்டா இந்த போர்ஷனுக்கு வந்துரும். Here you need to simply click join with nickname. There you need to type the nickname is your permanent roll number. I said, say example 19E101. If you type your roll number, if it is already your exact nickname, means it will don't throw any error. At the same time, it will ask you to click that's me. On behalf of 101, I am going to click this. You can't find this nickname. Please try.
Sir, enakku appadha sir vanduchu.
How many of them facing this issue? How many of them facing nickname error issue? Okay, please unmute and tell. How many of them facing this nickname issue?
Sir, 101.
Sir,
101. Wait a minute. 19E 101 இருக்கேமா? Okay, sorry. Now you try. Can anyone else facing this issue?
119, sir.
119. Now you try.
Okay, sir.
Can anyone else facing this issue? Can Selvaraj, are you there? Selvaraj 116 Jayavardhani 119. You people need to join using the classroom link. Okay, not from your account. Vikram, are you there? Vikram? Can others parallelly you try to do? Okay, now I'm going to start the demo simulation demonstration. Okay, yes. So whenever you create your account, okay, immediately you will get this window. Here you will find a few menus: 3D design, circuits, code blocks, and lessons. Out of this, we need to click circuits. Is it clear up to this? And please say yes or no. Sir, Sundar Ganesh sir.
சொல்லுங்க சார்.
சார் அங்க கொஞ்சம் ஜாயின் பண்ணிருக்காங்களா சார் கிளாஸ்ல?
இதுவரை யாருமே ஜாயின் பண்ணல
சார். ரெஃப்ரெஷ் கொடுத்து பாருங்க சார். ப்ளீஸ் கிவ் ரெஃப்ரெஷ் and check sir.
Yes sir.
If you give refresh, you can check this blue color indication. The blue color indications are giving that they have joined. The name on the blue color la irukano. Abhisidhu, Aishwarya, Akshay, Aravind, Arun, Avinash, Gogul, Gautam, Jayavardhani, Jeevan Raj. இருக்கிறமா இல்லையா?
சார்
Google
சில பேர் அக்கௌண்ட்னு டைப் இருக்கு சார்.
சார் அந்த அக்கௌண்ட் இருக்கிறவங்கள கிளாஸ் ரூம் வழியா வர சொல்லணும். செல்வராஜ் கொஞ்சம் அன்மியூட் பண்ணி பேசுறா, கத்த வைக்காதரா. செல்வராஜ், செல்வராஜ் ஆனா உசுரா வாங்குறீங்கடா. உங்களுக்கு கிளாஸ் எடுக்கிறதுக்கு போயிடலாம் சொல்லி. ஏண்டா ஒரு மைக்கை அன்மியூட் பண்ணி பேச சொல்ல முடியாது உங்களுக்கு? எக்கடா கெட்டு போகணும், முடியாது. யார் பேசுறது?
சார் செல்வராஜ்.
மைக் என்ன வாடகைக்கு உட்காந்துக்கிறியா? இந்த கண்ணே பொண்ணே மணியேனா உங்களுக்குலாம் வேலை நடக்காதுடா. எத்தனை தடவை கூப்பிட்டு இருக்கிறவன நானு? லாகின்ல கிளாஸ் ரூம்ல கிளிக் பண்ணி நிக் நேம் கொடுத்து ஜாயின் பண்றான்ற நீ திரும்ப திரும்ப உன்னோட அக்கௌண்ட்லயே உள்ள வர. புரியுதா புரியலையா உனக்கு? புரிஞ்சா பண்ணு, புரிஞ்சா பண்ணல விட்டுருவாங்க. ஆனா டே எங்க இனிமேல் நான் யார்ட்டையும் ரிப்ளை கேட்க மாட்டேன், நான் பாட்டு கிளாஸ் எடுக்கிறேன். தயவுசெய்து நான் விட்டுருங்க, உசுறு போகுது உங்கள்கிட்ட கத்து. கிளிக்ஸ் கிரியேட் நியூ சர்க்யூட், சர்க்யூட்டை கிளிக் பண்ணிக்கோ. யூ வில் கெட் ஒன் விண்டோ. ஆனா ஒரு மனசாட்சி இருக்கா? 80 பேர் உட்காந்துருக்க, கத்திட்டு இருக்கிறேன், எவனா ரிப்ளை பண்றியா? கிரியேட் பண்ணிக்கோ. யூ வில் கெட் திஸ் விண்டோ. நீ எப்படியும் காப்பி அடிச்சு ஏதோ ஒன்று பண்ணுவ, புரியுதா? அது எங்க எதுவும் நடக்காது. அந்தந்த லிங்க்ல போய் தான் நாங்கள் கரெக்ட் பண்ண போறோம், ஓகேவா? பட் எனிஹவ் நீ என்ன பண்றன்னா ஃபர்ஸ்ட் கிரியேட் லேபிள், டைப் யுவர் ரோல் நம்பர், ஓகேவா? உறுப்புன்னு நினைச்சா நீயா வர, இல்லைன்னா எவன்கிட்ட காப்பி அடிச்சு வர, சரியா? டைப் யுவர் ரோல் நம்பர் C1 to 7, ஓகேவா? தென் title will be in the some other name. Don't give the same name. Type the experiment number. Our experiment number is experiment number 5A. It is interfacing of LED with Arduino. Please type the full name. Okay, va? Experiment number. நல்லா படுத்து தூங்க வேண்டியது. நாளைக்கு வேலை கிடைக்காம 3 ரூபா சுத்துங்க. அப்பதான்டா தெரியும் உங்களுக்கு இந்த வலி, இந்த கத்திட்டு இருக்கிறவனோட வலி என்னன்னு தெரியும். அப்ப அப்படியே பெட்ல படுத்துட்டு உட்காந்துக்க வேண்டியது, இன்னொருத்தன் கத்திக்கிட்டே இருக்க வேண்டியது கடைசி வரைக்கும். எது காலேஜ் வரோம், என்ன பண்றோம், எல்லா ஹார்ட்வேரையும் ஸ்கிப் பண்ணிடுறீங்க. உங்களுக்கு வெறும் சிமுலேஷன் மட்டும் காட்டணும். நீங்க என்னைக்கு வாய் திறந்து பேசுறீங்களோ அன்னைக்கு ஹார்ட்வேர் பார்த்துக்கலாம். இன்டர்ஃபேசிங் ஆஃப் Arduino with interfacing of LED with Arduino. Interfacing of LED. அவ்வளவுதான். டைட்டில் டைப் பண்ணிக்கோ. டைட்டில் டைப் பண்ணிட்டு you need to take the Arduino. From where we can take the Arduino? Before that, click this down icon as a drop down menu and click all. Then you will find n number of components present over here. Here the thing is that we need to select the controller. So this is our Arduino Uno board. Please click, drag and drop. I repeat once again. Click, drag and drop. That's all. Very, very simple task. So this is your Arduino. Here whatever we have discussed, these are all digital input output pins. These are all analog input pins. These are all power pins. So we already discussed it. Okay, wow. Now our first exercise was we need to make this onboard LED to blink. Okay, wow. Eppadi sir blink pandrathu? So it's very simple. After selecting the controller, click code. If you click code, it will give some code blocks. We are not going to deal with the code blocks. We are going to writing some coding. So click this again, this drop down menu, and select text. I repeat once again. Select the controller, drag and drop. Then we are not going to add any external hardware. So therefore, click simply code, then click drop down menu, then click text, then click continue. I didn't return any coding, you know why. By default, they gave some coding. It's a C++ code. Itself they have given the notation. See, what we are going to do the same thing. Our purpose is to make the pin number 32 output. Already it is configured as output. Then digital write pin number 13 to high. What it means? We want to make the pin to logic high for some time. Okay. Then delay 1 second delay. Then low to make the pin to logic low. Then delay. Simple, very simple. Once you have written the code, simply I need to start simulate this code. For that, click the start simulate button. So here they are giving some additional features what they have added. They have added breakpoints, then variables you can pass. Okay. You can resume the simulation in a step time. There are some additional features are given. Whenever you find free time, you try that one. Okay, now we have started our simulation. You can observe the output. Can you see that 13th LED is blinking? 13th LED is blinking. Yes? Yes, sir. It's blinking. Yes. But you should not happy with this because you people are going to do many exercises in near future. If you are not getting output, you should capable of doing troubleshooting. Okay, that additional stuff we will teach you here. Take multimeter. So take multimeter. Here you can find voltage, current, and resistance. Here you can find two probe. One is positive and negative. Okay. Bring your multimeter nearby to your port number, pin number 13. Then connect pin 13 to positive terminal. Even you want to change the color, you can change it into red color. Then take the black color and connect it here and change it into black. What we are going to do exactly here means we are going to check what is the logic level the particular controller produces. Shall we see now? See, observe. 0, 1. 0, 1. It's not exactly 5 volt. Am I correct, sir? It's giving around 4.7 volt. But in a practical case, if you measure, you will get exactly 5 volt. In a simulation, it shows up to 4.7. This is the very, very big thing you should know. Whenever you are not getting the output, you should know how to troubleshoot and get the output. Okay, that is the idea behind why we have shown this simple thing. And also, here you have one more component to measure. Have a scope. You have a scope to measure this output. Can anyone tell me what may be the shape of the output? If you measure the output, what will be the shape of the output? You have studied various
Wire
forms.
signals.
It will be square waveform. Okay, if it's square waveform, you will be happy. Yes, it's perfect square waveform. Okay. How to get the little more square waveform? Duration korachalum appdiyada irukku. Reduce this. Okay, sorry, I need to scope put up by seconds. Okay, can you see the transition square waveform? So that's all the first exercise. But we are not going to deal with only the onboard LED. Always we will connect some external component to this. How to connect? Here you have a breadboard. There are 3 types of breadboards available. We are not going to teach the breadboard connection and all. Whenever you find free time, please spend time and learn this. Here we are going to connect some external LED. So from where we can get the LED? Here I have a LED. Then current limiting resistor we need. So let me take the resistor. So first and foremost thing, we will power the breadboard. Power the breadboard. VCC is connected. Now I am going to connect the ground. Change the color to black. That's all. So now I'm going to take the LED and I'm going to connect the resistor in series with the LED. The cathode terminal, if you watch this diagram, the cathode is connected straight away to the ground. Okay? Cathode is straight away connected to the ground. Then anode to resistor, then resistor to the port. Let me connect it in the same way. We put the resistor here. So how to rotate the resistor? Simply click this icon, thereby you can rotate your components. Not only resistor, all the components you can rotate it like this. So now cathode terminal straight away we are going to connect it to the ground. Anode terminal is connected to the one end of the resistor. Then other end of the resistor we are going to connect it to 13th. That's all. So first exercise is not blinking onboard LED. Interfacing of LED with Arduino. So we have interfaced LED with Arduino with one additional component, this resistor. Now is it we need to change the coding part? No, because our coding part remains same. We have connected LED in pin number 13. We can use the same code. Simply kick start simulation. Thereby you can see the output. So here you can observe two things. This is the power on LED. This is your onboard LED that is connected to the pin number 13. So that's all. First exercise is over. You people also can do the same and keep it in your login itself. Okay. Let me check whether Krishna Raj has tried something. No, he didn't start. Can anyone tell me if anyone did something from there? Let me check it here. Jayaprakash, Godwin, Sabari Shetty, Purushothaman. Purushothaman, have you tried anything? Try பண்ணுங்க. கொஞ்சம் ஸ்பீடா இருக்க மாதிரி இருக்கலாம் உனக்கெல்லாம் சரியா? வீடியோ ஒரு தடவை ரிவைண்ட் பண்ணி பாருங்க சரியா?
ஓகே சார்.
வேற யாருக்காவது see I need to address this later entry students because you people already Vasant understand ஆகுதா Vasant எப்படி பண்றதுன்னு?
எஸ் சார்.
ஏதாவது டிஃபிகல்ட்டி இருந்ததுன்னா சொல்லு Vasant சரியா? வேற யார் இருக்கிறா? வசந்த், புருஷோத்தமன், அரவிந்த். ஹேவ் யூ ட்ரைட்? அரவிந்த் இன்னும் நிறைய பேர் உள்ள லாகினே ஆகல, என்ன பண்றாங்கன்னு தெரியல. Okay, let them do it. No issue. So okay, now we have 6 more minutes. We will do a few more part. Okay. Yes. So we have few theory concepts over here. This one we have finished. Okay. Then this how to log in this. See, the diploma students may know about the AutoCAD. Endakana AutoCAD drawing படிச்சீங்களா diploma? Hello. AutoCAD படிச்சீங்களா? புருஷோத்தமன், Google, AutoCAD. So the Autodesk அப்படினு ஒரு கம்பெனி இருக்கு. They are providing many softwares. So அதுல ஒரு software தான் இந்த Tinkercad. So Tinkercad க்கு என்ன பியூட்டினா it is a cloud based software. So you don't need to install anything. Just simple login and do the work. Okay, ma? Then here we finished these two. What is the task to you people? Connect two LEDs and try to make that LEDs to blink in an alternate fashion. Please note down the question. We will show you the animation also. We will show you the animation also. Can I the LED how to identify the anode cathode and all you know when? Am I correct? Nearby the flat surface you have a cathode. So whenever you do hardware connections at the time, it is very, very important, because if I cut the lead in the same length, it is difficult to find which one is the anode and which one is the cathode. So okay, so on the difficulty avoid panna, you should remember. Then how to calculate the how to design the resistor. Please take the screenshot of this one. Different LEDs will operate with a different operating voltage. And according to the voltage required for by the LED, you need to design the resistor. Okay, it is simple voltage divider equation, and or else you can simply apply Ohm's law and to find the value of the resistor. So these are all few design purpose, design concepts. You need to know how to design that current limiting resistor. Okay. This is a detailed calculation. If you want, please take a screenshot. Then what else? What else? About this Arduino IDE demo hardware setup, we will see in the next class. Okay. So this is a task we have given. Make the two LEDs to alternate in this fashion. Try pannalama? Try pannalama? Definitely try pannalama. Okay, wow. This is the task sir. Where the task try pannu. Off delay increase pannu, on delay increase pannu. Try panni paru. So these are all few additional tasks you people can try. Using same pin number 13, change the delay and check the blinking pattern. And alternate LEDs. Try pannu. Then 4 LEDs. With limited coding. Coding portion limited. Okay, wow. I'll try pannu. Next, we are going to see the switch interface. Switch interfacing is also very simple. The syntax is a digital read. Digital read. Here, in the argument, you need to pass only one thing, that is your pin number. Digital read. Can you tell me what pin number you will type here? Enna pin number la type pannalam? என்னென்ன பின் நம்பர்லாம் டைப் பண்ணலாம்? ஹலோ, என்னென்ன பின் நம்பர்லாம் டைப் பண்ணலாம்?
1 to 13.
1. What about 0? 0 to 13 you can type. 0 to 13 you can type. Okay. So input அப்படினா pin mode ல input output நம்ம pin mode யூஸ் பண்ணி கான்ஃபிகர் பண்ணிரோம். Inputs are used to read the data from the sensor or the switches. Outputs are used to write the data to your actuator or output devices. Okay. Example LED. Here the example is switch, simple dip switch. Okay, wow. Read and write function. Okay, wow. Let me give the simple clips how to interface the switch. Please observe the slide. And tell me what is the condition of the switch, whether it is an open condition or closed condition. Switch open irukka, closed irukka? Switch open irukka, closed? Open irukku. Okay. Open. Can you tell me the logic level at the input pin? Inga enna kedaikum? What you will get it here? இந்த இடத்துல உங்களுக்கு என்ன கிடைக்கும்? Input pin. Here what you will get?
Sir, indeterminate.
Indeterminate. That means what? Okay, if my switch is in closed condition, what you will get? If my switch is in closed condition, what you will get? Switch வந்து இப்ப க்ளோஸா இருக்கு, என்ன கிடைக்கும்? What you will get? Switch close-ஆ இருந்தால் என்ன கிடைக்கும்? Switch closed-ஆ இருந்தா what you will get it here? You will get same VCC here. Am I correct? If it is open, it will be considered as a floating state. Floating state. Closer the here you will get logic high. It is not a logic low. It is in a floating state. How to avoid that? How to avoid that? You will see in the next class. Okay. Try to browse how to avoid. We start from here and we will see little more demonstration and we will start the next lab. The condition is that before entering into the next lab, you people must finish this experiment and come to the lab. Okay. Okay, we will check in your logins and then you login la complete பண்ணிருக்கணும். பண்ணிருந்தீங்கன்னா you will get attendance in the next lab. Any difficulties, please approach us before getting into the lab. That's all from our side. Sir, is it 4:15 no sir? Any time? It's 4:15. Yes. Sir, Sudhrunesh sir. Okay, if you have any doubt, you can ask.